Hey everybody, this is my recap of the 2016 free response problem about the circuits. I already went through it, but then the upload failed, so I'm going to go through it again. So I've already written this stuff out. But this problem was talking about a circuit with a battery and 4 identical resistors as shown. Look in here, this problem... see, first thing I noticed, that this is the positive end, this is the negative end of this battery, and if I follow the current going this way, I see that A is in series, getting all of the current, and then B and C are in parallel. And then that current splits off, some goes across B, some goes across C, and then others go across D, and D is in series with this battery. So... the question of what's happening with this parallel, I thought a great way to approach this was just to say, you know what, let's assume every resistor is 10 ohms and let's see what happens. And that highlights a few things about parallel and series resistors. A 10 ohm resistor is just a 10 ohm resistor. That's what it's equivalent to, because that's what it is. But a 10 ohm resistor and a 10 ohm resistor in series are 20 ohms. That's 2 resistors that the charges have to go through. One after the other. And then this 10 ohm and 10 ohm resistor connected in parallel, well, that's equivalent to a 5 ohm resistor. And that might seem crazy that 2 resistors can actually combine to make less overall resistance, but think of it like lanes in a highway. That there's less of a traffic jam going on. It makes it easier for traffic to flow when they add another lane. The 206 bypass is being built in Hillsborough, Montgomery area to reduce traffic on 206 to give people another way to travel around 206. And it'll cause less congestion in both spots and make it easier for the charges to flow overall. So that means that we actually see 40% of our total resistance at A, 40% of our total resistance at D, and only half that, 20% of our total resistance at B and C. Or I put it in fraction form right there. 2/5 V, 2/5 V, and 1/5 V across both B and C. That's how the charges will be able to get through there. That means that your rankings are A and D are the same, which are both greater than B and C. Great. Now, when B is removed, that changes some things about this circuit. Instead of having a parallel branch in here, this entire thing is series. Everything is consistent. All the current, from the battery to A to C to D, nothing is flowing up here anymore in that gap. So, what happens to the current through resistor A? Well, I said it decreases. A has less potential difference than it did before, since I equals delta V over R. I decreases. And I drew that on here, and that would be a great thing to add on the question, is to say, hey, look, the potential difference is 1/3 now. This is 1/3 of the resistance in the circuit, where before it was 40%, and that's a decrease. Some people also explain this one by thinking about the total resistance of the circuit. And you can see the total resistance goes up because C by itself has more resistance than B and C connected in parallel. Before, if they were both 10 ohm resistors, it was 5 ohms of equivalent resistance here. But now it's 10 ohms. So with more resistance, that decreases current through the whole circuit. And that means A has less current than it did before, because there's more resistance everywhere, and A reads the total current. C, however, gets more current than it did before. If you look at the math, I equals delta V over R. The delta V from here across C went from 1/5 to 1/3, and that was an increase in delta V. And with an increase in the potential difference and the same resistance, that'll be more current. Instead of it's splitting up, now some goes, like everything has to go through C. Even though it's a little more, it's not that much more. It's not quite double the current, but it's definitely more. So, those are my thoughts on that one. Feel free to email with specific things that you got. This was a great question about series and parallel resistors and their effects on voltages and currents.